Welcome everyone, and welcome to the SQL 2025 conference. This is a session about vectors, AI agents, and databases, and I am Davide Mauri. I'm a PM in the Azure SQL team, and I focus on Azure SQL, developers, and AI, and especially when all these things are together, like in this session. And I'm very active in the community. You can find all the details on these slides. I blog quite a lot. Follow me also on LinkedIn, Twitter, and Blue Sky to make sure that you keep updated with all the fantastic stuff that we are adding to SQL Server and Azure SQL. And 2025 is going to be a great year, so make sure to stay tuned. Having said that, let's just go quickly over the agenda, which is pretty small because we'll start with the introduction and just an overview of vectors, embeddings, and agents. And then we'll move to understanding how we can build an entire end-to-end solution using agents and maybe how we can do it in pure T-SQL and see it in action. So what are AI agents, first of all? Well, an AI agent is a software that is able to do autonomously what basically you ask it. So it is, for example, is able to go and retrieve the data from a database, or even open a web page and retrieve the information, or create an order, or do whatever it has been trained to do. The AI agents are really cool because they just allow you to basically talk to them in natural language. So one of the things that we will be doing today is create an agent that is able to find SQL samples for you, and samples with AI and SQL together. So you may be asking to the agent, find me a sample to build AI agents in SQL, and the agent will do stuff behind the scene. You just have to wait and sit and enjoy a cup of coffee, for example, and then the agent will come back and will present you the result. Those results can be in natural language or in what we call a structured output. We will see that second one today because it's very interesting, especially when you use it within a database. But that's pretty much it. So the idea of an agent is pretty much what you have in mind already. Just instead of being a human, is AI construct that can just do something that you ask it to do. Why AI agents that are so common today needs vector and embedding to work properly? Well, the point is that embeddings are numeric representation, in other words, vectors, of data like words, images, or items that capture the meaning or relationship with something. And those are crucial for AI because that allows AI agent not only to do precise search, like, okay, find me all the data that was created at this moment in time, for example, so very precise, or all the products are red in color. But it helps the agent to do all the semantically similar queries that you may need to do when you don't have a precise question. Like, for example, if you want to find books about science fiction, the Foundation series by Isaac Asimov is probably something you're interested in. And the embeddings can capture the information in form of vectors about the Foundation series by Isaac Asimov, about the fact that an agent is looking for science fiction books, and put them together so that the agent can, in quote, understand that the Foundation series by Isaac Asimov is actually a science fiction book or a series of books, and then return to it if your ask is, find me next science fiction book for me to read. So those are kind of the foundational aspects. Let's now make a more practical and business-related example. And let's take a fictitious insurance company that want to use Agentic AI to improve the workflow of their human agents. So let's say we have a human agent that is about to meet with John Doe, and he wants to find anything that is in the system about John Doe so he can be prepared to meet the customer and make sure he is happy and loyal. So the human agent will actually work with an agent that we can call orchestrator here to basically ask a question like, hey, I'm meeting with John Doe later today. What can you tell me about him? The orchestrator agent will take care of communicating with other agent, asking the right question so that he can ask the CRM agent return all the information about John Doe, like the address, the information about the number of cars or houses or whatever that he has insured with us. The claims agent to get information about the latest claims or the past claims and understand how they were managed. And the payments claim to understand, is this customer paying on time? Are we charging him a lot, or we increase the premium lately? So everything that is helpful to answer the first question. And of course, behind the scene, each agent will be able to run queries or create queries or find information in our case, database that is appropriate for their work. And they are actually able to create the query on their own. Of course, you can have a storage procedure they can call, you can prepare some code they can execute. But since you don't really know what the human agent will actually ask to your agents, yes, you can definitely prepare some tools for an agent to use, as we will see later. But also, you want the agent to be able to completely be free in asking a question to the database or actually creating query and executing those query so that they can return information that are needed to answer the question. So this is the first super important step. Agents are able and will be more and more able in future to create a SQL statement on their own and execute those statements. So this kind of change a little bit the way we approach as a developer the creation of our application. It's really a revolution, in my opinion. In fact, you will not be the one writing the query that will be executed against the database anymore, but the agent will be the one creating and executing the SQL query. Of course, you can limit the scope of the agent, maybe using storage procedure and functions, but still, if you want to give to the agent the maximum flexibility to answer any question, then the agent will write the query. It will not be yourself anymore. So this is a very big mind shift, especially from a security perspective, because now you don't control the query anymore, or you have a very limited control. So you need to make sure that the data is protected using other tools like row-level security, like correct security on database, because otherwise, possibilities of leaks or misuse are always around the corner. So this is a very, very important topic, in my opinion, as agent will become more and more common. And again, they will be writing and executing code against your database. So from a more practical perspective, what could be a simple example of an agent that is able to understand the natural language query that you are submitting, deciding what to do, generating SQL or executing a storage procedure just to simulate a little bit more complex solution, and then providing the final answer. Well, that's what we are going to build. So we will have an LLM here that will understand the natural language, decide what to do if an approximate answer or a precise answer is needed. In the first case, it will generate it will execute a storage procedure using vector search. In the second case, we'll generate a query with a where clause, and then execute the query, get the result, enrich them with data, and then merge back with the structured data, and then finally return the structured result. So that's it. That's the demo. Before moving to the demo, I want to answer a couple of common questions, like how do I apply this concept to my application? Well, first of all, agent frameworks are becoming common. There are a few samples in this conference also. Semantic kernel is one of my favorite, but there are many available. And the main problem is that what happens if you already have an application and you cannot just change it, right? Maybe it's an existing application that could be changed but requires a lot of effort. Maybe you just want to have a KISS approach, so keep it simple, push the AI in the database and make it available to you, any of your application without changes. So in either case, you probably want to see, even just for a learning perspective, how everything can be done in T-SQL, and then you can decide if to use an agent framework or not. So let's start using T-SQL to create a very simple application end-to-end that allows you to search using natural language all the samples that are related to AI in Azure SQL or SQL Server, and find the one that is most appropriate for the question you are asking or for the sample you're looking for. Okay, so this is the example I've been mentioning as the simplest one that I could possibly think of an agentic AI RAG solution. And basically what we can do is just search in natural language and let the agent figure out what is the best way to do to solve our question. So let's start to say, show me the sample used at SQL Conf 2025, and let's see what happens. In this case, of course, this question cannot be answered just using SQL. So we need to do a more semantic search, and it looks like the AI bot correctly returned the answer because it is saying this sample is relevant as it was used at SQL Conference 2025 and demonstrates the integration of various Azure services to create a functional AI search website. The other option where the AI needs to make a choice is if we ask, show me the last 5 samples, for example. And in this case, there is no need to do semantic search. So another tool should be used actually in this case. SQL query should be executed. And here we go. We have the latest 5. So what is happening behind the scene? So this is the GitHub repository. And what happens is that when you search something, the storage procedure find sample is executed. And first of all, what I try to do here is get embedding of the text to search if I already have provided, if the AI model already provided an answer, so we can use semantic caching. If yes, we just return the cached result. If not, then we call this function called this storage procedure called orchestrate request, which is where the magic happens. So let's take a look at the orchestrate request. And what is happening right now is that I am telling the AI model, so here I will be connecting to an AI model, that you are a SQL Server database assistant. You can answer question providing the correct T-SQL query to get this result. And here I'm specifying the structure of the table that I want to use or that I want to be available to be used by this AI agent. And you can see here I'm just limiting the schema that is available to my model to basically to query my table. So I'm not adding the title, I'm not adding the description because I want kind of direct how the agent will be using this table depending on if it is trying to do a precise search or a semantic search. So in this case, I'm just saying, okay, for you, just pretend that only these columns exist. And then I just tell that the T-SQL must return a JSON document. So using the for JSON auto statement. So I'm explaining my AI model how it should behave. Then I specify here the question that the user has asked, and then I define the schema. This is very interesting. I define the schema that must be used by the AI model to return my result, and specifically my result contains 2 columns, if you want. The response type, so if a query is provided, there will be the response type called SQL, otherwise none, if the answer cannot be answered just generating SQL. For example, I'm asking something about session title, which the agent doesn't have access to that column. So it will say I can't answer that just running a SQL statement here. And if the agent can answer using a SQL query, then I want to have the SQL query in this specific property. And now, since the data is returned in JSON format, then I can ask the AI model to basically understand what I'm asking, return the answer. And then here I will have a result that will tell me, is the agent able to generate a query for your request, or it needs to use something else? For example, a semantic search is needed. Because we know for this specific code that I'm writing that if a SQL query can be generated, then we have to switch to semantic search, which involves the execution of a storage procedure that I have prepared. The agent framework are able to automate even more this approach. So they will automatically be able to figure out if a storage procedure needs to be executed or not. This is just a starting point for you to get confident with the agent. So I'm doing everything manually, but the principle is basically the same. There is an orchestrator that needs to decide what to do, and then it can either ask to do something using a tool, a storage procedure in my case, or can do directly something, in this case, writing a SQL query and executing it. So at the end of the orchestration phase, I will have an output, so the result output and the query output. If the result is a SQL query, then I will just try to execute the SQL query, making sure in my case, again, this is an example I want to show some best practice to make sure that the SQL doesn't contain anything I don't want it to contain. Or if the SQL has not been generated, which means that we can't use SQL just to query that answer because we need to do some semantic search, then I'm helping the AI model here to do semantic search using the new vector distance function and the new vector support that we added in SQL. And the reason why I need to help the model is that the model has been trained before we release this feature. So the model itself doesn't have knowledge about the existence of this function. So I can do two things. Or I either provide what is called a few-shot prompt, where I show the model how to use these new features, or in this case, I prepare a kind of a tool. Imagine this could have been another storage procedure. In this case, again, for the simplicity of the example, I'm just showing it in the most simple way possible. And here I'm just helping the AI model to execute the right query to return the most similar samples that are related to the question being searched. Once the results are done, basically I just take the samples generated and I ask the AI model to generate an answer. Now, generating an answer here is, again, it's very simple because basically imagine right now that we either have the result generated from the SQL query or the result generated by the semantic query. Now, what is left to do to fully implement the RAG pattern is to take the result and pass it again to another LLM model to make sure that only the proper results are returned, given the provided question. And that is exactly, again, what I'm doing. So here I am now saying, okay, this is if you want, the second agent. So we had the first agent that was orchestrating the request. Then we executed some tool that the agent told us to execute. And then now this second agent takes the answers and finish the RAG pattern saying, okay, you are a system assistant who helps user find code samples. So you see the difference is how I am using LLM models here. The first one, the request was decide what to do, basically, or which tool to use, SQL or the storage procedure or the semantic search. And in the second usage of the LLM model, I'm saying, okay, now that I provided you with the answer that I think may be in scope for the question, understand if those answers are in scope and return the full answer. So here I'm just completing the RAG pattern, giving the examples to the LLM model, providing the original text and explaining it what I expect it to do. And then the result again is returned as a structured result. So I don't want a natural language answer. I want to have the result in a very specific format. So I want to have the result position, the ID, a summary of the sample, and the thoughts that the AI model had while deciding to return that specific sample. So I will return like 10, I will give the AI model 10 examples, and it will only return to me the one that are relevant. I want to understand each of the sample return, why it thought it was relevant. So I will find that here. And then I just run my query against the AI model using a pivot external REST endpoint, because of course my AI model is outside database, is in Azure AI, and then I get the result and basically return the result that are again a JSON document here. So if I go back to find samples, you will see that the result here are returned opened as JSON, so they can properly be returned as a table. So let's take a look behind the scene what's happening on database, because that gives us some interesting result. So here I'm connected to the database. So let's take a look at the semantic cache, because aside of caching the result to provide a faster response without using the LLM always, here we have some information on, based on the query asked, what is the action that the agent decided to take. In this case, it generated a query, and as you can see, the query is very nice, very elegant, and it just contains the 4 JSON auto clause as I asked. And so in this, to answer this question, the agent decided to generate a SQL query that has been executed, and instead to answer this other question, it decided that it should have gone for a semantic route and execute a similarity search query. So very nice, very simple, very powerful, right? Again, I have not written, there is nothing in my code that where you can find this query. Now, this brings to me to a very important discussion about security. Let me open a file that shows you the importance of row-level security here, and why it's so important that you start to take a look at that. And gladly, we have it in Azure SQL since long time ago. So let's move out a bit from our example right now, and let's just say that I have a table with some sample data, right? So let me make some space here. It could be our samples, it could be anything else. For now, I just have a table with some sample. Let me create this example, and now, okay. Now what I want to do is show you that even if I'm an administrator, or even if I impersonate the identity used by the agent, I can instruct Azure SQL or SQL Server to show me or the agent only the thing that we are allowed to see. So to do that, I need to, in this case, just again for my example, create a table where I store the security levels of my users, right? So I'm setting myself to have a security level 0, which is one of the most privileged, and the agent, specifically its managed identity, to 1, which is a little bit lower. Okay, so let me create, I think I already did, but just in case. Perfect. I create the user agent identity. In this case, I'm just simulating it with a local user without a login. But just imagine that this is the identity used by the agent when connected to the database. I'm doing everything locally here for trying to stay within the 30 minutes allocated for this session. So otherwise I would have had a function or a container running my agent, running my code actually, running the website that would have connected to Azure SQL presenting this identity. Here, we're just simulating it. Okay, so now we have a sample data. We have a table where we can associate a user with a level. And what I want to do is create what we call a row level policy that says, okay, if you are a certain user, I can check the level and return 1 if your level is above or below a certain threshold. And if it's 1, means that you are authorized to see a certain row. Or if it's 0 or nothing, it means that you shouldn't see that row. So let me create this function. And now I apply the policy. I'm saying whenever someone queries the sample data, take the security level column that I added to my sample data table, security level column, and pass it to the security level function I created. So the level will be passed as an input. If the level is it's outside the boundaries of 0 and the level that I set here, then you can see the query. You can see the row. So let me show you. Now, of course, this policy is set to off, so it will not be applied. And if I query the sample data, I can see everything, right? Now, who is the person, the identity I'm using here? Let me show you. So I am the DB owner, which means I am the administrator here. I should be able to do everything. Now, the moment I enable the security policy, you will see that I will not be able to see the row -1 anymore, even if there are nowhere clauses here, no predicates. So this data is gone for me. It's like it doesn't even exist in the table, even if I administer it. So this is the power of row-level security. It works at a lower level than your query, and it makes sure that all the data returned is authorized to be shown to you applying this logic here. And this logic is very simple. As long as 1 is returned, and imagine it is just a logical explanation. Imagine that this function is executed for every row. It doesn't work in that way, otherwise it will be very slow, right? But logically, imagine that this function is called for every row, and the value of the security level passed as a parameter here. So the value with security level -1 is not shown to me because I have security level 0. And -1 is outside the boundaries, so it's lower than the security level I have, so I'm not shown that row. Now, what happens if I change my user and I impersonate the agent? I have set the agent to have a security level that is a bit lower than mine. So the agent can only see the rows that have a level greater or equal than 1. So let's see what happened. Now I am impersonating the agent here. So if I now execute the query, well, in this case, I probably even forgot to give myself permission. So let's go back. That's good. That's another good example of permission. I need to grant the permission to the agent. Let me go back. Let me impersonate the user again, execute the data. Now you will see that the agent doesn't even see the row number 0. So it's very, very important that row level security is applied at the database level to make sure that no matter is the query, here my agent could write anything, can write also something like that, but that will not trick the system. It still only show the data that I'm allowed or I want the agent to see. So just imagine someone trying to hack into the prompt of your agent, trying to make the agent do something that is not supposed to do. This is a huge security guarantees to make sure that your data cannot be leaked. Now, if I go back to my user, of course, now I'm back administrator, but the row level security is still in place. I can't see the row with value -1 anymore. This row here is just like it never existed to me or to agent. And of course, I can also change the data. The table is absolutely a regular table, so you can add data, remove data, update data, and based on security level, following the function I created here for the example, I will be able to see or not see any row. So that's very important because the moment the agent will access the database on your behalf, you want to make sure that the agent can only see what you want it to see, to make sure that, again, no one can abuse the agent and hack into the prompt and maybe ask the agent to do something that it was not supposed to do in first place. That's it. So let me clean up the database and let's go back to the slides. Okay, so you have now a complete picture of the end-to-end solution. We just focus on the database side, of course, but the example you have seen, which is available here at this address, comes with a full end-to-end solution with the front end in React, the database that you have seen already, and data API builder that is discussed also in other session of this conference to act as your backend for front end. So you can have a very nice end-to-end demo that you can deploy in your subscription. Now imagine doing what I did instead of samples on your document, on your customer data. And if you want to have a even more complete example and even more realistic example using semantic kernel to orchestrate the agents, you have the ultimate chatbot demo that is available at the URL that you can see in the slide. But also you can ask the website linked in the first resource about show me the insurance sample demo that Davide created, and it will return to you the right one. You will see a more complex example, actually the one that I described in the slides before, with the claim agent, the payment agent, the CRM agent, all working together to basically answer your question. Then make sure that you check out the devlogs, because I'm blogging a lot. My colleagues are blogging a lot about all the features that we are releasing. And again, 2025 will be a very interesting year for SQL Server and for the AI. And in general, then if you want to have access to all the AI, a single place where you can find all developer resources, go to azuresql.dev and you will find plenty of things for you to have fun with. Thanks a lot for coming to or watching my session. Make sure also to take a look at the path that we created, develop data-driven application that will give you a kickstart in using Azure SQL to create modern application. And with that, have a great day and see you next time.